Okay, 6 o'clock. We will get started. Okay, 6 o'clock Pacific time. We'll get started. So last week we are on the sorting algorithm. That's chapter 9. Okay, today we will be on the chapter 10 AP lab. Okay, and after the parents, what will we do? Okay, we will continue to work on the algorithm. So we do not finish. Okay, we are not finished yet. So parents are on the multiple choice, but after that we will be primarily on FRQ design patterns. Okay, so we still have 2-3 weeks to go, including today. We still have 3 weeks. Okay, we still have 3 weeks for review. So today we will be on the week 10. Week 10, actually, if you look at the parents book, it will be on the AP lab. Okay. So before we go through these different algorithms that we would like to go to, let's actually first work on the problem set. Okay, let's work on the problem set first. There are not too many problems, so let's go through it first, and then we'll come back to the algorithm portion. Okay, so let's work on the problem set first. Okay, so let's actually work on this one. This one I also post it to the group, okay? And then after we finish the problem set, we'll go back to review of the algorithm. So here, let me actually post it first. Because the AP lab, we do not have enough time to go over the AP lab, okay? So we can only review on the problem. The AP lab, there are 7 different labs. There are 3 major labs you need to go through. One is the chipboard lab, okay? Chipboard lab. Another one is the picture lab. And there's another one is the 11th lab, okay? So they did not test you on the lab by itself. They did not directly test on the lab. But they will test on the concept that covered by the lab, okay? The concept covered by lab will be covered. And there are 4 more labs actually given later by College Board, okay? But we primarily work on these 3 labs. So I have already posted to the chat box, okay? So let me see, let's get started. First, let me have Henry, okay? Henry, can you work on the first problem?
Yeah, just let me read through the problem real quick.
Yeah, take your time, okay? So basically here you have an age group, okay? And then there's a category. You try to assign a category to these, okay? So you have 1, 2, 3. So let's look at 1. Is 1 okay?
No.
What's wrong with it?
So basically, so basically it will assign a senior adult as well.
To assign senior to adult as well. So what happens, you assign a senior if it's greater than 65, right?
Yeah.
Second time, you will assign greater than 18 to be adult. So this one got overridden. So here, missing an else, basically. Is that okay?
Yeah.
Okay, missing an else. There's a missing else. So this one's wrong, okay? Second one, is that okay?
Yes.
No, second one is not okay. What's wrong with second one?
Is this not okay?
The second one is not okay. Yes.
Is it because you're not allowed to have 2 inequalities?
Yeah, there's no such thing as
Yeah.
A greater than 1 and A less than 3. This is not okay.
Okay, yeah.
This is okay in Python. If you write some Python program, this is okay, but not in Java.
Yeah, okay.
Okay, so this one wrong because of this. How about third one? Third one is okay?
Yeah, third one's okay.
Third one have to be okay, otherwise no answer, right? But anyway,
yeah.
Third one actually you do have the else, so that's okay. So one is that what we talk about, okay? Second one, we have Damon, okay? Damon, can you work on the second problem?
Okay, wait, let me see.
So all of the problem you see right now, actually, in the AP lab, they do exercise on this concept that we have here, okay? They do exercise on a concept. The AP lab do cover it, okay? But we do not have the time to cover it because one lab would take more than 10 hours to finish it. So we don't have the time to cover the lab. It can only be it can only be taught in the regular semester. So how to solve this problem?
A,
How to solve this problem?
I guess you just go through it.
How to go through it?
So first, it asks you the index of the first O,
And then what do you get?
which is 1,
Which is 1, okay? And then
greater than 0.
Mhm.
Then it goes, so it prints out 1.
1, okay? And then
It creates a substring.
what do we create?
So substring index plus 1. So guess from index 2 until the very back.
What do you get?
What do I get?
Yeah. What do you get by doing this?
So this, wait, does it give you just like everything behind the second? I mean everything behind the first O, everything behind index 1.
So what would that be?
The W.
W,
DO.
yes. Okay, so starting from here. And then
Yeah, then index equals to star index of O. Then it just repeats. Then the second one you get
So what do you get from here now?
2. I mean, yeah.
2? No, you didn't get 2.
Oh wait, 3.
So basically this one, this one, why I keep asking you is that I need to make sure that you understand the procedure to solve it. So the procedure is that you write something like this way, okay?
Mm-hmm.
And then you got an index, you cut it, this one, you cut it, yes, you cut it, and then you get index. So you put down 0, 1, 2, 3, so you print 3 second time, and you cut it from here, right?
Mm-hmm. Yeah.
And then you actually continue. You continue, you get 0, 1, 2, so you put up 2 here, you cut it here, right?
Mm-hmm.
And then the next one, actually, you continue 0, 1, 2, you get another 2. Okay, I'm missing a U. Okay, I'm sorry. I'm missing a U over here. So it actually should be 0, 1, 2, 3. Okay, the O should be 3. So you print out this way. Is that okay?
Yeah.
Okay, so what I want to say is in the exam, you need to be able to list down this by yourself. Okay? That's the way you solve the problem. Number one, if it's actually related to index, please write down. You can write on top of here, but if the space is too small, it's better that you print it out by yourself. Okay. Okay, when you do it, actually, because it will cut in the middle, so it is not okay to do this. Okay, if you continue to write this, it doesn't help because later you are going to, you will become useless. So you would rather that you actually cut this one over here and you restart the counting over there. And every time you actually restart it, okay, then it will solve your problem. Okay, so that's the way you should do in the exam. Number 3, let me have James Lee on number 3. So number 3, there are some bugs. You need to change something. So what's wrong with number 3? without looking at the solution. What's wrong with it? Can you tell me which line that has a problem?
So one of the lines has a problem.
Yes, and can you explain how this remove all work?
Let me see.
First, can you try to explain how it works? Okay. It's very important that while your friend is answering the question, you also working on it. Okay. If you haven't, it's also very important that you also working on it at the same time. Okay. Because we are reviewing, we want to make sure that you understand. Okay. And if you have the solution or you have suggestion, if you are not a student, I'm asking. You are. It's also okay that you actually provide your idea. Okay, we are in a discussion mode. We are not just asking a certain specific student. So, what's wrong with this program, and what does this remove all really do?
See that it creates an empty string, and then it checks to see if the position of the phrase with ch.
And then
-1.
Mm-hmm.
So if it is, it returns that phrase, or returns the phrase, and then
you return what?
It returns the phrase that's the input phrase.
This one, you say this one?
Yeah.
What does this mean? What does POS equals -1 really mean?
It's the position of ch within the phrase that was input.
That was -1. So what? So what does that mean?
It means it's not in the phrase.
Not in the phrase, yes. For example, if you try to search for a character C, but there's no such character C, then you will return the whole phrase. So what does this really means? That you return phrase. You try to search for string, but there's no character C, and you return it by yourself. So that means that no change, right? This one actually means no change. And in what case is no change? When the character C is not in there, you do no change. Okay.
Yeah.
Otherwise, what will happen? Otherwise, if there is a C, what will happen?
Then it adds a new phrase.
What does this mean?
From substring 0 to position.
Well, what does this really mean?
So it creates a copy of the phrase, and then
it doesn't create a copy of the phrase. No.
What about line 4? What does that do? Or is that just a constructor? Line 4.
Line 4. Line 4, is that a constructor? No, it's not a constructor.
Is that constructing the?
No, it's not a constructor. It's just pointing the new phrase to the same location that phrase is pointing to. So phrase pointing to here, new phrase also pointing to here. That's not a constructor.
Oh, okay.
So what does this really mean? Here, what does it try to achieve?
It's adding the substring from position 0 to the position that's the index is found of ch.
So what that really means?
I'm not sure.
So if you have a character C and then you found the location of this guy as POS. So what does this mean?
It returns, it's the index of the value, but before C.
Before, yeah, and then what does this really mean? This whole thing really mean?
the whole substring from the first position until that one.
Until POS -1, yes.
Yeah.
So what does this really mean?
It just returns that substring.
So from where to where?
And then it adds it to the string.
From where to where? From where to where?
From 0 to position 1 -1.
So actually this?
Yeah.
No. It will not be there. Okay, it actually will return from 0 to position -1, but not including position -1. The second index is not included. The second index is not included. So here actually it's missing the letter. Okay?
So in the code.
And then what happens? So this one assigned to string. So now string become, so if this portion called A, now string become to have an A part, right? And then what happened? And then what happened?
And it assigns a new phrase to
new phrase,
the substring
of
from
new phrase.
0 to the.
So what does this really mean?
It adds the substring.
It doesn't add actually.
After position C.
No, it doesn't add.
Or no, it creates it assigns a new substring.
Assign a new substring from where to where?
Just from position C to whatever is after that.
No, it doesn't include the position C, doesn't.
Or yeah, it doesn't include it. It returns the one that's after it.
So actually it cut it here, same as the previous, but we cut it here. So this one become your new phrase. And then
it assigns the index of CH to POS.
Where it be? It actually find the next one here. And then
sees if that position is in the string.
If it's not, what
if
happens?
It's not, then it adds new phrase to str.
So new phrase, where's the new phrase you will add right now? So basically you get another B here, but B actually still missing one letter. And then eventually you will get C here. C actually you will still missing one letter. Another C. Okay, this is not character C, it's a part C. So apparently there's something wrong is this guy is wrong. Because of that guy, actually you always missing one letter. So the correct answer for this guy actually is you need to change it to POS, not POS -1. So it's here, B is wrong. Okay, B is wrong because of that. And the purpose of this whole thing, really is you have a string. There are many characters you want to find. So you really cut down this part A to the string, part B to the string, part C to the string, everything that actually without the A. So eventually it's called remove all because it's going to remove all of the character C from character CH from the string. Is that okay?
Yeah, makes sense.
It actually remove that, okay?
Yeah.
But this one, okay, the way you trace it actually takes a long time, but you need to get something study harder, okay? One thing I think you need to understand is the operation of string. This one you need to get a better understanding of it, and also the use of index function, okay? Is that okay?
Mm-hmm.
And this one actually, if you know how it works, okay, choose the problem. Answer is very simple, okay? This one actually, the answer is B, okay? Okay, next one we have this one Oscar, okay, Oscar number 4.
Yeah.
Here, I don't really care about you give me the right answer or wrong answer. I don't care. Okay. I really want you to really understand the problem. So here we have a position, index of, and then, okay, they are testing some function. Okay. So here it has a, this is since actually, the purpose of this function is in the chatbot. Okay. In the chatbot, you will use index of to find a certain position. Okay. And it's trying to match the whole word matching. There's no partial word matching. So if there's a certain sentence, right, this is a cat. We try to match the pattern cat. We should only say that cat, that is a match. If there is something called catch, then we say, no, this one is not a match. Okay. So the whole program need to actually show people whether it's a whole word matching or not. Okay. Whole word matching means that you only match cat, catch is not okay. Catch is not okay. You try to search for dog. You give me a pattern doggy, that is not okay. That's not a match. Okay. Okay. Keeping that as a background information. So what is the algorithm here? Okay. It actually try to have one condition. So what condition need to be added over here? Okay, over here. So first, let's actually also try to understand how this function really works. Can you tell me how this function really work?
Looks if there's like a space before and then after.
What this actually? What's the purpose of doing this?
It's like to determine if there's a space before or after the word.
It is a character before it or after, right?
Yeah.
If not, what will happen?
If not, then it's gonna go to the else, and then.
If not, it go to the else. If yes, what will happen?
Oh, then it'll set the before to be a space and after to be a space, so you know it's a standalone word.
Okay. And then what's the purpose for doing this?
To like find out that it's a space before and afterwards.
Yeah. And will they do it or not?
Yeah.
No, I say no. This one is one of the problems that actually parent has bugged. Parent make a technical mistake over here. This program basically doesn't work.
What's the purpose of the position plus word dot length equals statement dot length statement?
Hmm?
Wait, what's the purpose of the position plus word dot length? Yeah, what's the purpose of that statement?
That's my question.
Oh.
You need to answer me what's the purpose of doing this and this.
So that the first one checks if position.
Okay, the first one check that whether cat is beginning part, right? That we
Yeah.
know. How about the second part? Second part, check if cat is on the right side. Right?
Yeah.
Position will be here and plus the length is here. So it actually check if the cat already is on the rightmost side. Is that okay?
Yeah.
Okay, and I say this one is buggy because here this or is wrong, right? You say that if you are beginning and you said your before is empty string, after is empty string. No, this is wrong. It may have a CH. So this is not valid. It's totally wrong. You cannot say that I'm the first, cat is my first word, but you cannot say that after that I do have a space. That actually is wrong.
Okay.
Okay. So this one we will rewrite it in different way. Okay. It should be this way. Okay. It should be this way. This one parents make a mistake, and then it should be in this way. It should be it should be doing this. If actually POS equals 0, then we say before equals empty string. So separate the two statements, and if actually POS is equals POS plus word the length equals statement the length, okay? Then we do end equals empty string. So these two are separate issue. Is that okay?
Yeah.
These two are separate issue, and right here, parent make a mistake for combining them together. So that's a string that, okay, right now that's a string that actually do it in the way I described. So separate two if, and first if set the begin equal empty, and second set the after equals empty string. Okay, so this one give us the case that if you see a cat, the before string, if there's it actually the word is the first letter, then you actually have an empty beginning before, and then if the cat is the last word, you will have an empty end. Okay, this portion is correct. Now, what else do they do? Okay, continue. Continue, they do have a calculated before and after. So what does this before and after do? Here?
So the before takes a substring of the position and.
So it actually get the data here, right?
Yeah, yeah.
Get an X later and also get a Y later for end. Is that okay?
Yeah.
That's why they need to make a list of before and end. Okay, but they make another mistake. Okay, they make another mistake by here. This whole thing right here, they should put a curly brace here, not here. Is that okay?
Yeah.
So this whole thing before just prepare before is empty or a later X, or after is a space of another later Y. Okay, is that okay?
Yeah.
And then what you do?
Then you're going to
Test your later, before, and after, whether they are later or not, right? Is that okay?
Yeah.
Which one was successfully tested?
Wait, would it be
Is A, B okay? So one use greater than the square.
Oh no. That's
One
not
use compare.
That's
So
not okay.
group A, B, and C, D, E, there's only one is good. A, B okay, or C, D, E okay.
CDE. Okay.
Why is that?
Because you can't use like a regular comparison sign with string.
To string? No, yeah. So this one actually is CDE only. If here you compare the character A, right? Then that's
Yeah.
okay. But here no, they don't. Okay, they don't. So here you have to pick CDE in this case. Okay, so no, not AB. So CDE, which one is correct? So here should you use an and or? Before and after, should it be and or? You compare what? Should be and, or is not okay. Because before need to be space or symbol, no later, right? So actually, yeah. So basically, this one C is gone as well. C or here is wrong. Okay, D and E only one survive. Okay, D and E only one survive. Should it be greater than A and something, or should be less than 0, or this thing, D or E? Which one is correct?
It should be. Should be E, right?
Should be E, yeah, because A actually is telling you it's between A and G, but we don't need the A and G. Our whole word catch before and after must be non-laters. Is that okay?
Yeah.
Okay, so overall you can see that actually this one parent do have technical problem. That's number one. Okay, but we review it not because they have this buggy, but we really want to understand what it work, how it work. Is that okay? So this one, remember, if you want to modify it, you separate the two test conditions. This one setting the before, this one setting after. And also you need to remove this curly brace, put it over here. Okay, and then it will work. Okay, is that okay?
Yeah.
Okay, but as you can see, this problem, this one, number 3 and number 4, from the lab, it really not easy. Okay, it actually needs you to really understand some sort of program patterns in order to solve it. That is the trend for problem from the lab. Okay, if you never work on the lab, you will have trouble trying to solve it. Okay, trying to understand it. Next one, William Zai, please. William, how are you? Any questions so far for the student who did not answer question? Any questions so far? No? No question. Number 5 for William, please. So here you have the response. Okay, all responses are an array of the responses. Okay, so you may have hello, may have welcome, may have several messages. Okay, so now you want to randomly specify a certain message from the all response array. So how can you get it? Okay, this one for William, please. Hi, William, hear me? Hello.
Me? Oh,
Yeah. You.
okay.
I
Sorry.
just make sure that you hear me. Take your time, okay? But how to solve this problem? We have an array of all responses. And then how to randomly pick one. So this one is equivalent to you have an array of integer A, okay? And how to pick a random number from A array. Similar to that as well, okay? But here you actually will pick a random response. That's actually string type. So what is the answer?
I think it's D
Why D?
because it's either A or D, but if you do A, you can get index. Wait, no. I think it should be A because there's no index out of bounds. Because
How to determine whether it's A or D?
because if it's D, it's impossible to get the last index from all responses.
Okay, this one actually I may told you in the random number generator. Okay, you look at this one, you generate 0 to 1, right? And
Yeah.
right now you want to generate 0 to n-1, including n-1, but not including n. Okay.
Mhm.
So basically, because of this, it's very straightforward. You actually need to use n instead of n-1.
Yeah.
Because I will give you 0 to n, not including n. Quantization will be 0, 1, 2, 3, 4, 5 to n-1. Is that okay?
Yeah. So it's A.
So you need to do a quantization. Yes, you need that. You cannot convert it to string in this way. That won't work. This one, C, actually, there's no quantization. It's only a floating point. You will assign to integer, so that's wrong. This one actually assign n-1, so you will only up to n-2. It means 1 later. The last one, you return the integer, not returning a string, so that's wrong. So the answer is A. Is that okay? Okay, good job. Okay, next one, Amy. Okay, Amy, next question. Number 6. Okay, there are 2 algorithms. Okay, so algorithm 1 and algorithm 2. Okay, forget about the question. Okay, can you tell me how does algorithm 1 really work?
So for the first half of the deck,
Mm-hmm.
Excluding the middle one, if there is one,
Mm-hmm.
it switches.
Copy to somewhere else.
Yeah, it copies somewhere else, and then it.
So let's assume that here you have a car. Actually, is car 0, 1, 2, 3, 4, 5, 6, 7. Okay. Then this one is originally your car. So where will 0 go to? To the shuffle location.
2.
No, you go to 0. Okay. K set to 0. So your J equals 0, you go to 0. Is that okay?
Oh, okay.
So this portion is the first half. So you should cut over here. You only work on this one. So how about 1? Car 1 will go to where?
3.
Car 1 go. No, if from 0 to 2. So you go to the 2 location. Is that okay?
Oh, okay.
How about car 2?
3.
No, it go to 4 location.
Wouldn't it be at 1?
Every time you increase by 2. K always increase by 2. Your J is increased by 1. J is the index for car.
But if J starts at 0, at 2, it would be 1.
J, you look at it one more time carefully, okay? You look at it carefully before we, so initially your K is 0, right?
Yeah.
So your J of 0 assigning to shuffle of 0. Is that okay?
Mm-hmm.
And then your K become 2. So your J of 1 shuffle to shuffle 2.
Mm-hmm.
And then your J become 2 and K become 4. So your J is, am I correct?
Yeah.
Okay, the next one, 3 will go to where? 3 will go to 6, right?
6. Yeah.
Okay, how about, this is the first half. First half being shuffled to the even number location, right? Apparently. Apparently, they shuffle to even number location. How about second deck? I'm sorry, here I actually make a mistake, okay? Yeah, I make a mistake. This is not from 4, it's from 3, okay? Okay, it is from 3 shuffle to it. So how about the lower deck? 4 shuffle to where? You set a K to 1. So 4 will be shuffled to 1.
1. Yeah.
5 shuffle to 3. 6 shuffle to
7.
5.
Oh, 5.
7 shuffle to 7. Is that okay?
Yeah.
So what do they do over the algorithm 1?
Like generally, just what does it do?
So what's the problem with the algorithm number 1 for shuffling?
It does. There's no way of switching the first half and the second half, so then you don't get everything in there.
This one and this one, yeah. Second half and first half never swap. That's one problem. Second, 0 and 7 never got swapped. Car 0, first car and last car never got swapped.
Yeah.
Okay. And also, if you look at the index, this one, you will see that it actually is 0, 0, 0, shuffle to 0, 0, 0. Okay. So 0, 0, 0, shuffle to 0, 0, 0. 0, 0, 1, shuffle to 0, 1, 0. 0, 1, 0, shuffle to 1, 0, 0. 0, 1, 1, shuffle to 1, 1, 0. Okay.
Mm-hmm.
Am I correct?
Yeah.
And then 4, 1, 0, 0, shuffle to 0, 0, 1. And then 101 shuffle to actually 0, 1, 1. And then 111 shuffle to 111. How do you see over here? By the index, what do you see over here?
Where?
By the index, what do you see over here? You are 0 shuffle to 0, 1 shuffle to 2, 2 shuffle to 4, 3 shuffle to 3. What do you see over here?
It just doesn't shuffle at all.
No, it shuffles some of the point it doesn't shuffle. 0 it doesn't shuffle, 7 it doesn't shuffle, but basically this bit being moved to the last bit. Is that okay?
Yeah.
So for how many iterations you repeat? You go back to original condition.
What do you mean repeat?
Okay, initially you have 0, 0, 1. You shuffle to 0, 1, 0. 0, 1, 0 would be shuffled to 1, 0, 0 next time. 1, 0, 0 we shuffle back to 0, 0, 1. So every 3 shuffle like this, you return to your original location.
Oh, okay.
Do you see that?
Yeah.
Okay, so that's this algorithm. Okay, this algorithm actually is very widely used in computer science. Okay, called shuffling network. Okay, but anyway, that's algorithm 1. How about algorithm number 2?
So
What does this one really work?
for the entire set, it generates a random integer, which is the index, and then it copies it to the array and it like switches it.
Okay, so basically, your array you started to so this is a k is over here. Okay, it's just like sorting. Sorting you have the to be insert location or to be swap location. Okay, so k actually is a to be swap location. So you randomly generate a certain number in this range. Okay, in this range, and then you do swap with it. Is that okay?
Yeah.
After that, actually, the to be swap location k actually will do what? K basically you will actually, let me see, repeat generate random number from 0 to card number 1. Okay,
it makes an array from,
and then your k increase.
generated.
Okay, so basically the first one you do copy to the shuffle 0, right? Second one you actually pick one to that one. Is that okay?
Yeah.
Yeah. So basically, every time you pick it, and then you actually what?
Then you just set it.
Set it to be empty. So what's wrong with this? Set it to be empty.
Well, then you can't use that array anymore.
You cannot use that element anymore. But eventually, there's one big problem with this guy. It is that if you only have one card left, almost all of the neighbors are actually empty, right? So that one, you only have 1 over maybe 52 chance that you can get a card. Yeah, okay? So the problem with number 2 is what?
It's going to be really slow.
Not efficient. Is that okay? So number 1 is efficient, but not fully shuffling. Is that okay?
Yeah.
Number 2 will do full shuffling, but not efficient. Okay, then we pick the answer. Okay, these two actually I slow down. Just want you to understand the different way of doing shuffling. Okay, and number 1 apparently is not a complete shuffle. It's just some sort of swap location. Okay. Okay, which one is the force between 1 and 2? Okay, a disadvantage of 1 is you won't generate all possible deck. Is that right?
Yeah, that's true.
That's right. So we don't pick it. Okay, so that's actually right. For algorithm to determine the last element shuffle require an average of number of card call to do it. Yes. Take a long time, right? Number 3, algorithm 2 will lead to more permutation than number 1. Is that true?
Yeah.
Yes. Number 1 only shifting the permutation by 1 bit. Okay. So it's a fixed permutation. 3 times later, you will swap back the original condition. Number 4, in terms of runtime, algorithm 2 is more efficient. No, this one is not working. So the answer is D. Is that okay?
Yeah.
So this one here, you see, if you don't go through the algorithm, you don't know what's the detail, okay? If one is repeated for several times, you return back to the original state. Yes, I say yes, but if you don't listen to me, you don't understand it. Is that okay?
Yeah.
So the whole thing is, let's look at it. The whole thing is actually you do have shuffle, okay? So 0, 1, 2, okay, 3, okay, and then you go back to actually 1, this one, okay, this one, and this one, okay. So basically you repeat 3 times, you'll go back, okay. So basically your beat is shifting to here, then shifting to here, shifting to here. Eventually 3 times later, you will be shuffled back to your original location, okay? But this whole thing is very useful. It's purple shuffling is not really that important, but it is actually being used in shuffle network in discrete, okay? It is actually in fast, okay, Fourier transform, okay? In signal processing, actually, it's using this shuffle network, okay? It really do this shuffle network. I'm not kidding, okay? This one is actually very advanced algorithm. Is that okay?
Yeah.
I'm not kidding. It's really very useful and advanced algorithm. Okay, number 7, let me have another person, okay? Number 7, let me have Damon, okay? So here again, it's buggy. So tell me which one is wrong here, okay?
Okay.
Take your time, okay? We don't rush you. Key point is that I want to make sure everybody understand it carefully, okay? Okay, one thing is for sure is that this one is just swapping the K location with random position, right?
Mm-hmm.
So there's nothing wrong here, okay? Nothing wrong here. So you swap K with a random position. So now is how you pick the random position and how this function work. So it only happen on here and here. Okay.
Mm-hmm.
So how does this work and what's wrong with it? Which one has error? Okay, there's 2 possibilities, right? There's one possible error is here. The K may be wrong. The other one is this K plus 1 may be wrong.
Mm-hmm.
Which one is wrong? Why?
If the case starts at num cards, it might be out of bound. It's
You directly cause this guy to be out of bound, okay? So this one must be -1. So why don't we do this? Why don't we actually do this one here? We actually don't +1. Will that solve the problem? If we don't pass the +1, we do this. Is that okay?
no.
That's not okay because this one will still cause the problem here. Is that okay?
Yeah.
So case location is the to be swapped location. Every time you prepare it to be swapped with other people, okay? So you must start from number -1. And you pick another location that's called random pause and then 2 swap, okay? Is that okay?
Yeah.
So then swap, you do not use a +1, you actually use a K, okay? You use a K +1, that's okay. That's actually would be 0 to num card, okay? It will actually make it to be 0 and n, but n actually not included, okay? So here, this one, okay. Just right here, you need to -1, okay? So this one, the answer is B. Okay, B. Number 8 and 9. Okay, let me have Henry. Okay, there's a tile class. There's a later and point value. Okay. So right here, if you want to print out such a format, okay, then which one is correct? Okay. Henry, please.
I think it's E.
Okay, so what's wrong with A?
So the issue with A is that, oh yeah. So basically, the letter, the word letter should be in front.
They
So
don't
it should be
have
quotation.
double quote. Okay, so A and C are gone.
Yeah.
So what's wrong with B?
I think it was the last what do you call it? Parentheses doesn't have a quotation.
The previous one also no.
Oh yeah, yeah.
So it's gone. Okay. What's wrong with D?
You don't need string because you're in two string.
Yeah, you actually no, not because you are in two string, but because this one is an integer. Integer will directly be converted.
Oh right, yeah.
With
Yeah.
With a mark. Okay, but you cannot convert an integer to string by using string convert casting to the string method. Okay, that is wrong. Okay. Number 9, let me have James. Okay, James Lee. Okay, James. Number 9. So two tile, you actually try to use a match. Okay. So 1, 2, 3, which one is correct?
Let me see.
Is 1 okay?
No.
1 is not okay because of what?
Other tile, or they're just using the method wrong.
One don't have measure.
Or it's not. It doesn't even have one.
1 doesn't have measure. So what's wrong with this comparison?
It just doesn't work. I'm not sure.
You're not sure, then why you say it's wrong? It actually is not working. If you are not sure, you cannot say it's wrong, right? You should say that I don't know, right? Am I correct?
I'm not sure what the reason is, but I'm pretty sure it doesn't work.
You say that you are pretty sure. How can you be sure that it's wrong? Since you are not, you don't know how it is wrong. There's no such thing that, okay, I know the answer, but I don't know why it is the answer. I don't buy these kind of things, okay?
Okay.
So can you tell me what's wrong with it? My question is that what you need to study and really know what's wrong with it, right? You're taking the exam, you need to know it. So what is later? What's the data type for later?
The letter is string.
String? Can you do string double equal sign another string?
No.
Why not?
Because you have to use the dot equals method.
You have to use dot equals, yes. But when you do double equal sign, what will happen?
If you use double equal sign?
Yeah. When you use a double equal sign to string, what will happen? Will compiler compile or no?
Is it a syntax error?
No, there's no syntax error. It still be okay. Compiler won't pick up as an error. They just give you false. Why is that?
Because
They compare the address of the string. They don't compare the content of the string.
Oh, yeah.
Okay, so this one's wrong. How about 2? Is 2 okay?
No, I
Why?
think. Because you can't use the this dot equals.
No, yes, you can do it as well. Compiler, no error. Compiler will not have error.
Mm-hmm.
Yeah. So what happened to this one? If you do this dot equal, what will happen? Anybody know? Amy, do you know? Hello,
And,
Amy, you hear me? Yes. What will happen to this one?
For number 3,
This
the
one.
third one.
2. This dot equals. What happened to this dot equal? So this one, you do have the tile class over here. So what will happen if you actually, number 2 is wrong. Yeah, we know, but why is wrong?
I think you can't use dot equals.
You can, yes, this compilation will pass. You actually can, okay? It will pass. But what's wrong with it?
I think this.
The time class does not have the equals function defined, right?
Yeah,
Then what will happen?
it's gonna throw an error.
No, it doesn't give you an error, no. You will call the equals function defined in object class. And what will the equal function in object class give you?
I didn't look at it.
Yeah, so that's the portion I want to review with you. Is that okay?
Yeah.
We don't want to just pass, okay, good, everybody pass. Then that you don't learn it. So this one equals function really, actually, you will compare just like using double equal sign. So you compare the address of this object and other tile, okay?
Mm-hmm.
And apparently this one will also give you false by default. Is that okay?
Yeah.
So that's wrong. That's wrong not because equals you cannot use. You can use, but when you use equals and then your tile class do not have a definition, then you will use the equals function defined in object class, and that will compare the address, so it's wrong. How about number 3? This one go back to James, okay? This one is your question. So number 3, is that okay?
Yeah.
That's okay, why?
Because it's properly using the dot equals method to compare 2 strings.
So that equals is coming from the string function. String actually have that equals. Is that okay?
Yeah.
So they will compare the content of it. So here it really tests you the idea of double equal sign equals function. Double equal sign is comparing only the address. Okay. Equals function, if you do not have a definition of equal function, it will actually call. In case that here you do have a definition for equals function, then we need to check whether that will be equal or not. Okay, that will be equal or not. But here it doesn't have the definition. It doesn't have the definition. It will go back to object class, and from the object class, you will use the double equal sign to compare it. That's a default definition for equals function. Okay, this one is very, very important. Okay, this one very, very important. We go into the depths. We try to actually ask you more difficult problem because you must remember this. When equals function not defined in the class, they will go to the object class. Object class will treat it like the double equal sign. Okay, everybody okay with this one? Henry, are you okay? How about Damon, are you okay?
Yeah.
Okay. Make sure.
I have
okay?
a
Yeah, question.
what does the other tile.letter do?
What did other tile that later do this one?
Yeah.
This one is actually a string that equals another string.
Oh.
So the equals come from the string object. It doesn't come from the object class. Is that okay?
Yeah.
So
Yeah.
it's actually comparing two string. Comparing two string by itself has the equals function defined, but not tiles. Tile doesn't have it. Is that okay?
Yeah.
Yeah, good to have question. Okay, this one will help you to understand the whole thing. Okay, this one number 10. Let me continue. The last time is James. This one Oscar. Okay, Oscar.
Yeah.
So what does this auto array really do?
Oh, it just like takes the end of the array. So like it reverses the array.
It reverses the array. Okay. So now we have a matrix and we do a reverse array of the matrix row 2. So what happened?
It's just gonna go to this 0, 1, 2. So it's gonna go to the last, like the bottommost row and just reverse it.
So you'll get this one reversed to 9056. Is that okay?
Yeah.
So that one should be this guy, D. Is that okay?
Yeah.
Okay, good. Next one, number 11. This one for William. Okay, William, for you. We try to go through the details so you make sure that you understand it, okay? So this is a D, what happened? Is 1 okay for D? For number 11, I'm sorry. Number 11. William, hear me?
Yeah, is 2 the only one that works?
Is 1 okay?
1 is not okay because portrait does not have constructor.
No, 1 is actually okay.
Oh,
If you don't have constructor, what will happen?
does it go super?
No, they don't go super. Yeah, they will go super, yes, but they will call the constructor with no argument. Is that okay? So it actually is okay. It actually will okay.
Wait, it will call the constructor for digital picture?
You call the constructor by itself. It itself has a constructor.
Wait, what?
Every class has a default constructor.
Oh,
Every class has a default constructor.
oh, okay.
Okay. Every class has a default constructor. I can try it out for you. So here, let me create a class. Okay, let me just create a stupid class. So this one is called ABC class. Okay, so this ABC class is over here. I'm going to actually take out everything. Nothing inside, nothing here. Okay, I just keep this one a dumb class called ABC, and then we do this one. We do test ABC. Okay. We do this one called test ABC, and we go to here, right? So ABC A1 equals new ABC. Okay. Even this, we don't have data, we don't have anything. The ABC actually is empty class. You try to call its constructor, you will call its constructor, and you will get this, the two string from object class. Okay, so here it actually do have the ABC constructor of no argument given to you for free. Okay?
Yeah.
So So they'll give you a free no argument constructor in this case. Okay. Okay. Anyway, that's that. Okay. So number one, is that number one? Okay. You assigning a portrait object to digital picture. Is that okay?
So is the answer 1 and 2?
One is one okay. I don't care about the answer.
Yeah.
Is
Yeah.
one okay?
Yeah.
Why okay?
Because everything has default constructor, and then you're calling digital picker. Digital picture. But can you do that? Because digital.
How to determine that one or two or three is okay or not?
I think it's because portrait is under digital picture, so one doesn't work.
Portrait under digital picture, so one doesn't work.
I don't know how this picture works. Like, does picture implement or extend portrait, or does portrait extend?
Portrait extend picture.
Then does.
So number one, you need to understand the UML drawing. Number one, you need to understand the UML drawing. This one is inheritance. Y arrow is inheritance. This one is impermanent. Okay.
Oh.
This one actually has a relationship. Has a relationship. Okay. This different drawing you need to know. That's something you need to know for the exam.
Okay.
So is one okay or not?
Then I think it's okay.
Why is okay?
Because you can make a portrait, and then it'll be cast as a digital picture.
You'll be casted to digital picture? No.
Yeah. At least I think
No.
so. No.
No. No. No.
Oh. Then I'm not too sure.
You're not so sure. How about two? Is two okay?
Yeah, I think 2 works.
No, two wrong. One correct.
Wait. It is
okay. So here I want you to really clear up your thought, your understanding for the classes. Okay. I don't care which one is the answer. I don't care. So one word, two wrong. Why?
Is it because landscape extends picture?
So how to determine? Okay, your digital picture running the digital picture constructor and assigning the object to it. I think 3 is okay for sure. Same class. You say AA equals new A. Same class should be fine. Okay, so no problem. Now the problem is that, okay, the problem is like 1 and 2. Should you use a parent class reference P equals new child constructor? Is that okay? Or child reference C equals new parent constructor? Which one is okay? Which one is not?
I think the first one's okay.
The first one is okay. Why?
Well, I don't have a reasoning. I just know that one works because
you don't have a reason. How can you know that it actually will work?
I don't know why. I just know it.
Yeah. So 2 doesn't work because 1, your child is bigger. You inherited your data field from your parent. Your parent is smaller. Child is bigger. So that's okay. If you create a parent object P, you try to convert it to child reference, like expecting more data field and function. You don't have that data field and function. So that's not okay. Okay.
Oh.
This one we explained it when we are in the chapter 4 or 5. Okay, when we do that. Okay, so this one correct answer is 1 and 3. The answer is E. Okay.
Okay.
But you do need to know about the detailed inheritance issue. Okay.
Okay.
We go through the detail just because we want you to learn it. Okay. Okay. Next one. Go back to Damon. Okay. Damon Wayne. Number 12. So there's a picture pixel, and there's a set rate function for it. Okay. And then there's a remove red. You will remove all of the red value. Okay. So with 1, okay.
Wait, I'm still looking.
So you do have an array. Each one of them is a pixel. Pixel may have its own RGB value, and you need to set the red to be remove the red color. So is 1 okay?
I think so.
Yeah, 1 is okay. 1 is okay because your this one pointing to a certain object. Your P also pointing to that object. P change, this pixel will also see it, so it's okay. Is 2 okay?
Yeah, 2 is okay.
2 is also okay. You don't need to assign to another pixel. So okay. Is 3 okay?
I don't believe so.
So what's the problem with 3?
You cannot just set it to 0.
Why not?
Because it doesn't work like that. You have to set it through the.
Because a pixel is a pixel type, is not integer type. Okay.
Yeah.
If the integer part is actually okay, but it's not. Okay. Number 13. Okay. Number 13. Let me have Henry. Okay. So Henry, number 13 is a matrix stuff. So you will do mirror. Okay. Mirror's job really is to copy from left side to the right side. Is that okay?
Yeah.
Okay, so that's the mirror's job. So here we do have one missing statement. What should it be? Which one?
I think C.
Okay, C. So between C, okay, and the D, why C and not D?
D sets so basically you want it to go from left to right.
Yes.
Like you want the left side to go to the right side. So
Yeah.
so D would actually make the left side equal the right side instead.
Okay. D actually copy the other way, right?
Yeah.
Okay, good job. So this one very important. Okay, number 1, in an array, okay, so the length is width, okay. So this one actually is 0. This one is the width minus 1 minus 0, okay. And the 1 location is symmetry location will be width minus 1 minus I, okay, minus 1. And I equals 1, okay. So if you have the location I, the symmetry location with width minus 1 minus I, okay. Remember that, okay. That's actually your symmetry location. Very important. Number 14, go to James, okay. James, number 14. So what does this author really do?
So it changes the row. If swaps the row and column order.
No swap. So you have 1, 2, 3.
Or it switches like the values
4,
that are in
5,
the row.
6, 7, 8, 9. It doesn't switch. It doesn't swap, it doesn't switch.
What does that last line do then?
Last line, what's the purpose of last line? You copy from row column to column row. What does this really mean? What does this one mean?
Oh, it changes the length of
No.
the rows and columns?
Row to column, column to row. It actually is copying from 4 to 2 or 3 to 7. Copying from your row change to column, column change to row. So it's a symmetric location over the two-dimensional matrix from the diagonal line.
Oh.
Is okay? So the whole purpose of this one actually is you are here, you copy to here.
Mm-hmm.
This one is a row column, this one is a column row. Is okay? Okay, anyway, that's the location here. So if you actually have a data over here, you will copy to here. Okay, now that's actually is the function of this one. But how many cells being copied? That's another problem. First one, we actually know that it's a copy across the diagonal line. But how many cells got copied here?
How many cells?
Mm-hmm. It goes through the 2 for loop and over 1, 2, 3, 4, 5, 6, 7, 8, 9. What are the cells being copied?
All of them?
Not all of them. No.
Oh, are 1, 5, and 9 not changing?
1, 5, and 9 not changing. 1, 5, and 9 not changing. Yes. How about 2, 3, 6?
2, 3, 6 switch with the 4, 7, and 8.
It doesn't switch.
Or they're copied.
Copy who? Copy to who?
They're copied to a new location. And
okay, first is that tell me how that is a 2 for loop traverse.
the first for loop goes through the row.
Mm-hmm. So it goes row 1 to the end of this. So it goes through these 2 rows, and then for each row, where do they go?
For each row goes through the column starting from 0 up to
what does this mean?
Up until column is less than row.
Where is the column equals to row?
At 2.
No, it actually is like this. Lower triangle. So if you have a data of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, you will only traverse through this region, the lower triangle of a matrix for this one. So basically only 4 copy to 2, 7 copy to 3, 8 copy to 6. That's it. There's no switch, there's no swap. It's just purely flipping the lower triangle to upper triangle.
Oh.
Okay? So that's why I want you to really go to the detail. Don't just tell me, this is switch, that is swap. It doesn't work this way. You have to really understand it. It's okay?
Yeah. I just
okay.
Didn't
but it's okay. You need to go to detail. Okay, what's the answer? The answer would be A.
Yeah.
You really copy from this side to that side. Okay.
Yeah.
And in the AP lab, it does work on this algorithm. Okay. It does work on this one. Okay. Anyway, we finished all the problem set. Okay. None of these problems are easy, but remember it's tested in the AP. Okay. Every year, I would say out of 40 questions, maybe around 4 or 5 questions actually from lab. Okay. I would say roughly 5. 5 out of the 40 questions, about 1/8 of the problem is actually from the lab. Okay. Don't overlook it. It's actually quite a lot, quite many points. Okay. So we finish this one. Let's have a 5-minute break. Come back on 7:25. We'll continue to do review, okay? Okay, now it's 7:25, okay? Any questions so far? Hello, any questions so far? No question? Albert Damon, are you okay?
Yeah, I'm fine.
Okay. Thank you, guys, to continue to stay, okay? Some students, when they know that we are going to continue to test online to ask top question, they may run away. But key point is, okay, only this top problem can help you, okay? Only the top problem can help you. If we just ask you, okay, A, B, C, D, which one it is, okay, B, okay, go. That's actually finish it, okay? Then you are not going to learn anything, okay? So don't get frustrated if the problem is really too harsh. It's okay. It's meant to be that way. Okay, we try to be giving you top testing, top question because we really want you to improve. Okay, if we don't care about you, I don't care about you, then I can ask you all kind of garbage questions, right? A, B, C, D, you answer it, and no matter what, I just say yes, yes, yes. Then that will pass. Okay, that will pass. Okay, so now let's actually continue our discussion. So today we will be reviewing FRQ. Okay, so we use a balance set to review the most of the multiple choice. Mostly it's done. Okay, so now we start to review the FRQ. So the way to review FRQ is you must remember the design patterns. If you don't know about the design patterns, you have nothing that you can use, okay? So one thing is that you must remember the algorithm. So I would say 90% of problems are covered by algorithm or some variant of the algorithms, okay? Maybe they are only 10%. You need to invent new algorithm. Only very few you need that, okay? So we will talk about both, but primarily on the one that actually covered by algorithm, because the one need to invent new algorithm, we can only give you the guideline, but we cannot give you the which algorithm will be tested. Okay, very hard to do that. Okay, but we can try our best to cover more algorithm if actually is existed. Okay, if it is existed. So today let's talk about some algorithm that may be tested in AP, okay? So the first one is the digit of every digit, okay? The digit of every digit, there are two ways to do it. Let's work on the first way, okay? So let's look at the digit. Okay, let's work on the digit. So here, let's assume that we have a number. That number is integer, okay, static integer, okay, num equals 1, 2, 3, 4, 5, okay, 3, 4, 5. So now if we want to print out every digit, just purely print out every digit. Okay, give me a number num and print it, okay. Print every digit. So here we have 1, 2, 3, 4, 5. How can we print out every digit? Okay, that's the problem. So if actually num actually equals 0, okay, then we do system.out.print line. We do print out the num directly. So this one is easy, okay. So if num not equal 0, we do this, okay. We do while actually num actually greater than 0, okay. We do the following thing. We actually get every digit. So digit will be equals what? Will be equals the number 10 multiplied by 10. This is one single digit. Okay, one single digit. That's one single digit. So we print it right away. Okay, and then we do a num, okay, equals num divided by 10. Okay, so this is a fixed structure. Okay, this is a fixed structure. You need to remember this successively division fixed structure. So basically something that is 1, 2, 3, 4, 5, okay, divide by 10. So you got 1, 2, 3, 4, and then 1, 2, 3, 4, okay. And then here you actually got 0, okay. And then here you have 5. So this 5 actually is the digit that you get first. This one is num 10 modular by 10. This number right here is called num divided by 10. Is that okay? Hi, James, is that okay so far?
Yeah.
By doing this one by one, so 1, 2, 3, 4, we continue to do that. You will actually take out 4 and then take out 3, take out 2, there are 1. So you will be able to take out every single digit. Okay, so this one's a printing digit, and we can do that. Okay. So this is a basic format that we take out every digit. Okay. Okay, so we print out num. You print out every digit. Okay. So first one is to visit every digit. It's a way we visit every digit. Okay. I'm sorry, I print out the wrong thing. I should not print out num. I should print out digit. Okay. Our purpose is to print every digit, not to print out num. Okay. Okay, so it's actually 5, 4, 3, 2, 1. Okay, so it's digit like that. So if we want to reverse the digit, reverse number, okay, so public, here if we would like to reverse the number, okay, reverse the integer num, okay. Same thing, we just copy it over, right? We copy it over. Okay. If the number is 0, okay, we will basically just return 0, okay. Otherwise, we go through it. We actually have 1, 2, 3, 4, 5, okay. 1, 2, 3, 4, 5. So we get 5, we should get 5, and then 4 will be after it, and then 3, and then 2, and then 1. Okay, so we get 5 first, right? So we will assign the 5 to a number called return value. So we have the R equals 0, okay? So we get that digit, okay? And we have a 5. Next time I get a 4. Next time I get a 4. I get a 4. My 5 should become 50 and then plus 4. Okay. Next one, I got a 3. This one should times 10 and then plus 3 in order to reverse it. So here I should have my R equals R times 10 plus the digit the new digit that I got. Okay, at the very end, we do return the R. Okay. So right here we do system.out.print line of the reverse of the num. This one will give you the reversion of the number. Any questions so far? Any questions so far for reversion of a number? Any question? Hello, Oscar, are you okay?
Yeah.
Okay, I'll give you a question now. Okay, try it. So now if I want to get the sum of digit, how can I do it?
You just loop through it and have like an exterior variable, add to MOA.
So if it's 0, you return it, right? And then?
And then you would go, sorry. And then you would go like, wait, do you want me to use a while or a for loop?
Whatever.
Oh, so then you go for. Or sorry, so you'd have like a an int sum.
So you need to have integer sum, yes, and then
is equal to 0.
and then at the very end you need to return it, right? So whatever.
Yeah, return sum.
So here we do set it to be 0, and
then you would have to like go through the different integers of some num.
And then how should I do it? Tell me what should I type?
Wait, didn't you write a method that already does that earlier?
So how can I do it? Just tell me what should I type, or what should I do right here?
So while
yes,
num is, I want to say not equal to 0. Like basically you keep modding num by 10.
Yeah. So what should I do? Tell me what should I do now? So while what?
Num mod 10 is not equal to num.
Num mod 10 is not equal to what?
Num.
Why is that?
Like, so if you'll keep going, so like you'll stop by chopping through it once you get to a single digit number. So like if num becomes 3, then num mod 3 is equal to 3. And then that'll be equal to 3. So then it'll exit the loop.
You asking the loop when you do that? No. Single digit, you still need to add that digit to the number. You still need to add it to sum. So this is what's wrong. You're down to 3. Do you need to actually still add a 3 to your sum? Yes, why not? So this one, no, this one is not the right way.
I forgot the.
Pay attention, okay? We already write the same algorithm for twice, here and here, okay? So this was still greater than 0, okay? We did this for twice already. So you get every digit by doing this, okay? Pay attention to the class, okay? And then?
And then you would go R is equal to, or sorry, num is equal, wait, what am I saying?
This one?
Didn't digit, num is not 10.
You get a digit from the number and then?
Then sum plus or sum plus equals digit.
Yes, sum plus equal digit. Okay, and then?
And then num is equal to num divided by 10.
Yes, num equals to 10. Okay, this algorithm is very important, okay? So must actually remember it, okay? Let's get every single one. We go through it, just we want to teach you in a very systematic way, okay? Teach you in very systematic way, okay? Okay, so this one is 15. That's 1, 2, 3, 4, 5 sum, okay? So here I'm going to go out of bound here, trying to get another one. So public, okay, static, okay, integer, okay, add digits, okay. So here for William, can you tell me how to write a function to count the number of up digit in num?
What? To count the number of odd digits in number?
Yeah. So for example, 1, 2, 3, 4, 5, you should give me a 3, since they are 3 odd numbers. How to do it?
I would maybe you convert it into a string, do a for loop to scan if Wait, no. Yeah, maybe you like scan every digit and then you match if it's equal to 13579.
So tell me how to do it. Okay, convert it to
Like
string.
int, wait, no, like int, count equals 0,
And then
and then s- string s equals num plus like what's it called, apostrophe, like no, quotation mark, and then you write a for loop for I equals 0, I less than num dot length.
num don't have less.
Oh, it's s dot length, s dot
there.
length. And then yeah, and then it's gonna be like if s dot substring I plus, wait, no, you're gonna have to do I is less than s dot length minus 1
What?
to avoid index out of bounds.
So okay, tell me what to do.
So in the for loop, instead of making the boundary I less than s dot length, you're gonna have to do I is less than s dot length minus 1.
No, there's no need. You got this already.
Yeah, but I want you to change that into it's less than s minus 1, because if you do substring I plus 1 on the last one, it's gonna be index out of bounds, right?
No,
It's not. Oh, okay.
you won't. Okay, you won't.
Okay. And then you just do if I, or if s dot substring I minus 1.
I minus one. It doesn't work.
Oh, I plus 1.
Yes.
Right.
And then
Dot, wait, dot equals actually that looks like a lot to type, so maybe you cast it as an integer, because it's
how to cast to integer? This one. How to cast this one to integer?
you just like parentheses int.
No, it doesn't work.
It doesn't work. Oh, well.
It doesn't work. It doesn't work.
Well, then you can just dot equals, or wait, you can do index. Wait, no, you can do outside of the for loop, you can make a new string.
Outside of for loop, you make a new string. So
You
here
can make a new
maybe-
string.
Yeah, new
No,
string.
no, that's not outside the for loop. That's inside the for loop.
So outside of for loop, you make a new string for what?
New string, that's 13579. Like string check equals 13579.
So let's assume that this is x is 13579.
13579. Yeah.
Yes, and
then you do if x dot index of s
guy.
dot substring, and then if it's not equal to -1, count plus plus. I don't know if that works. And then you return count, yeah.
This one will work, okay? This one will work, but actually you waste your time. We discussed the division, success division for 3 times. And you are inventing your new algorithm.
Okay.
It doesn't make sense, right?
Yeah.
Do you really pay attention to our discussion or not? Okay, that's a question, okay? Try to be more focused, okay?
Okay.
This one will work. I would say this one will work, okay? But there is a better way to write it. So at this moment, I'll try it out first, okay? It will work, okay? The one you say will work. But please pay attention to the class, okay?
Okay.
This one will work, but it's not a specifically good solution, because right here you are testing the odd number, but in certain case, okay, you actually end up 2 okay, end up with 2 greater than 0, okay, greater equal 0, okay. It actually greater equal 0. So that will give you 3, but this one is not definitely not the best answer for it, okay. So let's actually continue. We'll discuss this later, okay. We'll discuss your version later. It's not a best solution, but it's not the very straightforward solution as well. So here we continue our successive division method. We actually can copy the whole thing over from here to here, okay, and put it over here, okay, and here we actually can count the odd digit, okay. So right here you don't use the sum, you do a counter, okay, and here you do if actually digit, okay, a digit can multiply by 2 equals 1. Okay, count increase, that actually is our number. Eventually you return count. Okay, this one is very straightforward. We have been working on the same algorithm over and over again, just trying to apply to different problems. Okay, so this one, it will work. Okay, it will work in the same way. Okay, in the same way, you still get a 3. Okay. Okay, anyway, this one actually is like that, okay? So this one is digit. So if you really like the version you have, okay? If you really like the version you have, you convert it to string, you do something, okay? It actually is fine. It actually is fine, okay? So here you set a counter equal 0. You do not need this one, okay? You do not need this one. So let's call this one digit 2, okay? So basically, you get a substring. Okay, if you like it, actually is okay. Okay, if you like it, actually is okay. So basically, you can just do this. Okay, you just do this one, capture at certain I location. Okay, if you do substring, it's also okay. Convert it to string. Okay. And this one you do actually integer, that parse integer, that will convert a string to an integer. Okay, this one to convert a string to integer, and you take multiply by 2 equals 1. Okay, you have an extra string that's actually also okay, but if it is not that simple, okay. If it's not as simple, then you may have trouble, okay? If it's not as simple, you may have trouble. Right here, because you are using odd numbers, so it's fine. Okay, it actually is fine. So this one is the way we do number of the odd digit, sum of the digit, okay, different algorithm. And there might be cases that, okay, there might be cases that they want you to put the different digit into a list, okay, into a list, so that actually you can also work on that one. Okay, you can also work on that one. You actually can also make a list. Okay, so here you need to import the array list. Okay, so here we go through the traversal of each digit. Okay. So you create a new array list. Eventually, you are going to return it. Okay, all your digit you will return it. Okay, same thing right here. If actually if actually your num equals 0, okay, you will only have one digit, but that actually is 0. Okay, you will do this. You will do a list dot add. Okay, 0 into it. Okay, and then you will return a list. Otherwise, you can do the same thing. Okay, you can do the same thing. You actually will do this. You will do while. Okay, num actually greater than 0. Okay, you do the following thing. Actually integer digit. Okay, equals num 10 multiplied by 10. Okay, and then your a list that add a digit. Okay, and then you do num divided equals 10. Okay, so that one will give you make a list, array list for you. Okay, so here that's wrong this one. Okay, that's wrong this one. Okay, you get this one. Okay. Okay. So if we would like to have make the using the string to do conversion, is that okay? That actually is okay. This one has nothing wrong. Okay, this one is nothing wrong. So let's look at the so-called reverse. Okay, if we actually do the reverse for the number, that should be actually faster. Okay, that should be actually faster. So we can do public. Okay, static. Okay, and you will reverse it, convert it to a string. Okay, integer, and we do reverse. Okay. So you return integer. So this one let me call it revert 2. Okay. So here, if actually num equals 0, okay, we'll return 0. Okay, for sure. Otherwise, we could create a string equals empty string plus num. Okay, and then we will create a string called reverse. Okay, equals empty string. Okay, and then for integer I equals 0. Okay, I less than s the length. Okay, I increase. Okay, then you get what? You get 1, 2, 3, 4, 5, and then you reverse it. So your new data need to be put after it. Okay, so basically your R actually equals your R plus the what? The S dot character at I. Okay. Actually, the first letter you get it. Okay, so you actually need to put it in front of your R. Okay, you get every letter. So you get started from 1. 2 need to put in front of it. So actually, it actually put in this way. Okay, and eventually you need to convert that R back to the integer. So you do return integer type parse int of R. Is that okay? So this one will also work. Okay, this one is the second version of the reverse of integer. Okay. Any questions so far? Okay, still revert to it. Any questions so far? So either way will work. Okay, either way will work. That using string will also work. Okay. Any questions so far? But for some application, successive division is better. Okay. Any questions so far? Next one is that how can we check the exact word? Okay, check exact word. Check exact word means that, okay, in the example of the FRQ, we do see that. Okay, we do see that. We do see there's an exact word that we may need to check. Okay, this one a moment ago we do look at this one. we do look at this one. You want to check only catch or only dog. Okay, we don't want to has partial word. So CAT should not be ready. This one is exact word matching. Okay, this one is the exact word matching. So exact word matching here we have a different way. Now maybe actually is even better than the one that suggested by it. Okay. So basically we can check if the whole string equal the pattern that you're looking for. So if the whole word actually matching the pattern, so it's only a cat, that should be, okay, that actually should be, that actually contain that word, okay. Second, if the pattern of this equals 0, that means that it has a leading the late cat, but followed by a space, then it equals 0, then yes, that actually is what? That actually is a match, okay? Or if actually you have the space followed by the pattern, okay, plus the length of that equals string length, that would also be the pattern, okay? Or it had leading space or actually trailing space. So this one is even a faster algorithm than the one presented in where? It actually is a faster algorithm than the one presented in here. Is okay, even if this one is correct. Does that make sense? Any question about this one? If you need to check the whole word, okay. Any question about this one? James, are you okay?
Yeah.
Okay. This one is okay. It's just a check different pattern, okay? Next one we have string formation, okay? This one is show up in one of the problem in the FRQ. If you do the College Board FRQ, you should see this one, okay? So here is actually 2016 question 4. It do have this question. So the question is, usually you use a typewriter or a text editor, okay? So you do something, you write something. And then say the whole line may be 80 characters, but you only have 50 characters. So there are certain spaces you need to specify in the middle, okay? In the middle, okay? So let's do this, okay? Let's actually, before we discuss this question, let's look at another problem, okay? Let's look at another problem. So let's look at array, okay? Let's look at array. If I want to print out an array, okay, this one very important. If I want to print out an array, okay, okay, if I want to print out this array and I want to print it in this format, I want to print a bracket and 1, 3, 4, 5, and 7, okay? So they are 5 numbers, but there are only 4 comma in there, okay? There are 2 ways that I can print. One way is I print 1, okay? Any number after the first one, you print 3, 4, 5, 7. This is the first way I can print it. Second way I can print it is I print 1, 3, 4, 5, and the last one I only print a 7. Okay, both will work. Okay, both will work. So let's actually look at it. Let's actually convert the scene to a string. Okay, so list A version. If I have array of the A and I'm going to listing the A into a string, okay. So here I have a return string equals, it will start with a left side bracket, okay. And at the very end, my R will plus equal my right side bracket, okay. And then I will return my R, okay. So starting with a left side bracket, ending at the right side bracket, okay. There's no problem. Next one, I'm going to list down every number, okay. So for integer I equals 0, I less than, okay, I less than 8 length, okay, and I increase. So I go through every single number, okay. I go through every single number. So I say, if I equals 0, okay, then R plus equals A's I's value, okay, without printing comma, okay. And then otherwise, actually R will plus equals, I put a comma and then the number, okay. So this one will solve the problem, okay, this one will solve the problem. So here, let's do. Okay, this one will print out the list over A, okay. And you print out the format that we are familiar with. Wait, it will be like this, okay? It will be like this. So now let's try a second algorithm. Second algorithm, we call it list B, okay? So give me the array B, okay? So here let's have the string, return string R equals, this one I use a curly brace, okay? And at the very end, I actually R plus equal right side curly brace, okay? And in the middle, I still go through the for loop, okay? So here, if actually I equals 8 length, that's the last one, okay? If this is last one, we actually do R plus equals, okay, A, this one. We do not add the comma after it, okay? Otherwise, we'll do this. Otherwise, we do R plus equals, okay, A's I's value plus the comma with space, okay? And this should also work. It will print out a similar way, okay? So this one eventually will return R as well, okay? So these are two ways we can list a array into a string, okay? Any questions so far? So let me upload the two different code to you, okay? After class, I may also send it, but right now I allowed you to look at it, okay? Let me copy it, upload it. So let me upload this array and the so-called digit, okay? Any questions so far? Okay, so this is the printing of toString, okay? How about James, are you okay?
Yeah.
So these are the conversion of this, okay? So now there's a question of this balance problem, okay? In the 2016, in the 2016, a question of the editing problem for the text is asked, okay? So usually when you edit in the text, they are left aligned, okay? They are right aligned, they are center aligned, okay? They are also justified, okay? So the question being asked actually is this a justified way of listing your word, okay? Listing your word, okay? So basically, number one, how to jump the number of the words in a line, okay? So given that, for example, we know that there's 80 character, you need to fit into 80 character, okay? And you have already some words, okay? How do you jump into a justified paragraph? Okay, this actually is a problem. Okay, so this one for William, are you okay? How to do it? You have a big string, okay? So every time you only have 80 characters you can use. How could you know that how many data that you can put into a line? Hi, William, hear me? Hello, William, hear me? Hello, hear me? How about Henry, hear me?
Yeah.
Yeah, how to do it? If I give you a big string like this, and how do you determine whether the line can be fit into, how many words can fit into the line of 80 characters? How could I know?
How many words can fit into a line of 80 characters?
Yeah.
Well, you have the paragraph, so you just count up. So in a while loop, you just count up until you get to
So you keep counting up.
something greater than 80. So you keep track of a counter, and that counter adds every single time.
But you still have
you
the
go
space.
through
You still need to have the space you need to worry about.
Yeah, so if you recognize, for example, an ASCII value that is greater than 96 or something, which is either a space or a comma or any quotations, then it will just remove it.
So if one word, right? One word, you actually just know about the length of the word, that should be fine, right?
Okay.
It actually need to less than equal to 80, right? Second word, if you have the second word, you should have a total length together plus one space at least. Need to less than equals 80. Three words, you actually need to plus. So it actually is a number of words.
Number of words plus the number.
Minus one. This thing need to less than. Use that as a criteria to add one word at a time until there's one actually overflow. Is that okay?
Yeah.
And the version before overflow should be used before that. Okay, that's actually good. Okay, that actually should be good. Okay, anyway, this is a problem. You do alignment, and then there's so after that you already know it. So there's a format length. Format length, you already know that. And then there's a string. Okay, you actually keep doing this. Okay, so that is a format string. There's a centered. Okay, and there's a justify algorithm. Okay. So basics, there are different ways you can do it. Okay, so justify program is like you kind of split the whole token into the string into a token. Okay, and you actually try to calculate how many total lengths of the tokens, okay, and then calculate the gap and then left over, okay. But here we omit one step is that we do not check if the whole token can fit into one line or not. We are assuming yes, okay. We are assuming it, but there's an extra algorithm you can use, okay. You can do that. Next one, we're going to the K-map. Okay, K-map is actually upper triangle and lower triangle. Okay, this one is used to check the equality checking or generate pair. Okay, or shortest distance or reverse orders. Okay, or friendship matrix. Okay, this one we call K-map. This one happened many times. Okay, so let's assume that we have a problem that you're given four different letters A, B, C, D. Okay, we need to generate the combination of all of the two letter combinations. So you have A, B, A, C, A, D, B, C, B, D, and then C, D. Okay, so they are totally 6 possible combination out of the 4. Okay. And BA is assuming to be the same as AB, so we do not repeat it. Okay. This whole thing, we actually call it K graph. Okay. K means complete graph. Complete graph. So we have 4 number. Okay. We have 4 number. There are 6 of them. 6 relationship. So if we only have 2 number, it's A and B. So only AB will be generated. 3 number, we have AB, okay, BC, and then AC. So there are 3 possible combination we can generate. 4 later, we can generate 6 different combination. Okay, so the number of 2 pair, okay, number of pair that we can generate from n number of symbols is a Cn pick 2, okay? That should be n band divided by 2 band divided by n minus 2 band, okay? Is that okay? Okay, so it actually should be n times n minus 1 divided by 2. Okay, that's the number that, okay. So that's that. But in program, how can we generate it? Okay. In program, how can we generate it? So we do have A, B, C, D, okay. We want to create all the combination. So you have A, B, C, D. So one way you can do is that you use the upper triangle to generate it. So this one, you can generate AB. You can generate AB, okay, AC, AD, okay, BC, BD, and then CD, okay. The other way you can use it is actually you can also use a lower triangle to generate it. You generate BA, CA, CB, DA, DB, DC, okay. Either way would actually create a pairs, okay, all the possible pair, all the combination in the 4 letter, using the 4 letter. Is that okay so far? Damon, is that okay?
I'm still kind of trying to get it.
This is very important, okay? Take your time. So green one is C4 pick 2. Red one is also C4 pick 2. Damn, is that okay? Now?
Yeah. Now it's here.
The green one and the red one both will work, okay? But you just need to traverse one of them. Okay. How about Henry? Are you okay?
Yeah.
This one very, very important, okay? James, are you okay?
Yeah.
I'm not kidding, okay? This one really very important. Let me show you where it actually has such a problem, okay? It's tested by College Board, okay? It's not even from the parents set, okay? It's not actually tested by College Board, okay? And it's not really an old problem, it's actually quite a new problem. Just 2-3 years ago, you've got 4 or 5 years ago, it actually got tested, okay? So it actually coming from the one we just released, very just on Friday, I think I sent it out, okay? This one in the College Board 2018 set, okay? 2018 set, there is a pair problem. When you have the pair problem, you will need to have this K-graph, okay? So let's see, this one is wall pair. Yes, this one is wall pair, okay? So you have the first string and second string, you need to generate wall pair, okay? So right here, question part one is actually, you have array of words. Please create all of the possible pairs of the words. We create all the possible word you have, okay? So basically this one is the one using this K-graph problem, okay? So for example, like here you do have 1, 2, 3 string. You have the C3 pick 2. You end up with 1, 2, 1, 3, and 2, 3. Is that okay? So this 2018 problem is exactly the one we are looking at. 2018 Q2 is using K-graph to solve it, okay? Will it repeat? Yes, I will say so. You repeat and you may actually continue, okay? Is that okay? Okay, anyway. So that's the so-called K-graph problem. Okay, so now let's actually try to do it, okay? So let's create this the so-called K-graph, okay? So here let's actually have a array of strings, okay? Okay, that's this one that actually have A, okay, B, okay, and C, and D, okay, and we would like to print out all of the possible combination of such a array of string, okay. So we will do upper triangle this time, okay, upper triangle. So public, okay, static, okay, print upper triangle, okay. Okay, so upper triangle, we have A, B, C, D, okay. We have A, B, C, D. We have A, B, C, D. We would like to print only the upper triangle corners, okay? So we go from here to here, okay? So I from 0 to I less than n minus 1, okay? So the I row should go in this way. So for integer I equals 0, I less than a length minus 1. Okay, and then I increase. Okay. Now each row, J was started from. Okay. When my I equals 0, J will start from 1. So J will starting from I plus 1. And then J will go to the end of the array. So it actually 8 length, okay? And J increase. So right here with system.out.proving line of my A of I plus A of J. Okay, this one will print out the combination of the all possible combination of the string in the A array. Okay. Will this be tested? Yes, I would say very likely in the future. Okay. Very likely in the future, you will need to work on a problem like this. Okay. So this one is to print the upper triangle, okay? Okay, an upper triangle, we will end up with 6 possible combination, okay? How about if I don't print the upper triangle, I print the lower triangle, is that okay? It is also okay. You will also be able to generate all of the possible combination. Okay, so let me use another one called public static. Okay, void. Okay, and then print lower triangle. Okay. So this one, let's be careful. Okay, let's be careful. We have A, B, C, D again. In the column, we have A, B, C, D again. This time, okay. This time, I'm going to traverse only through the lower triangle here, okay? So basically, my I starting from 1 to the end of the array, okay? To the end of the array. So my I starting from 1 to the end of the array, okay? My J is starting from 0, okay? And J will less than I. In the diagonal one, I will be equals J, okay? So J will be actually less than I, okay? In the lower triangle, and J will increase, okay? Then we send the same thing, we print out this A's I and J, okay? And that's actually print it in lower triangle, okay? This is another way you can do traversal to generate all the possible pairs, okay? Okay, any questions so far? Any questions so far? No question? So any question about is a print upper triangle or lower triangle? Any question? This one is to print up the pair, okay? When you need to pair something, you would like to go through all the possible pair combination. This is the way to do it, okay? James, are you okay?
Yeah.
Any question?
No.
No question. Let me ask you a question. If I want to generate ABCD from ABCD, created the possible ABC 3-letter combination, what would be the possible combination of the 3-letter? You have ABCD that you can use.
The amount of possible combination?
What are the possible combination that you can use the ABCD to create 3 letter? Right now, we are working on 2 letter. How about 3 letters? 3 letter combinations. How many? First, how many combination is there?
Is it 3 factorial?
Not 3 factorial.
What was it?
No. It's a 4 letter, you pick 3. So this one. How many?
3 factorial is 4.
Equals 4. Okay. So it's always only A, B, C, A, B, D. Okay. And then you do have, let me see. Okay. You do have A, C, D. Okay. And then you have B, C, D. Is okay? 4 possible combination. Is okay?
Yeah.
How to do it in program? Hard, right? Not easy, right?
Yeah, I'm not sure how to do 4.
Okay, this one is just basically you copy your upper triangle one. Okay. So put it over here. Don't call it upper. Okay, let's call it pick 3. Okay, you want to pick 3. So here we do have ij. Let's add one more layer that we actually use for integer k equals j plus 1. Okay, k less than 8 the length. K increase. Okay. So here, this one I change it to -1. Here I change it to -2. And here I say plus A of K. Okay. Okay, that's it. This one will do pick 3. Is that okay? The 4 combination being generated. Okay. Okay, so the idea is that the first one, A, you fix. So your second value can only be B, C, or D. Okay, so it traverses every single one of them. Your B is the second one. Your third one, you may have C or D. Okay, and if you are C, okay, if you are C, you can only have ABC. If you are D, you have ABD. Okay, if your second letter is C, you can only have actually ACD. Okay, AD impossible. Okay. The first letter you may have a B, okay. B you may be able to call BC, D. Then nothing else. And if you have a C, nothing, D impossible. Okay, so totally 4 possible solution. Is that okay? So this one is pick 3, okay, pick 3. But I don't think the pick 3 will be tested. Anyway, you need to at least know about upper triangle and the lower triangle. Okay, that actually is something you need to know. Okay, you need to know. So here, let's give you another problem. Okay, that's actually called points. Okay, points. So this is a point array. Point actually we may have. So we may create a class called a point. So this class point we actually do have we do have two data fields. Okay, we do have a integer x and integer y. Okay, and we do have a constructor. We do have. Let's make it simple. Okay, so we do have integer x, integer y. Okay, and then this dot x equals x. Okay, this dot y equals y. Okay, and we can also calculate the distance between one point to the other. So public, okay, double, okay, actually distance. Okay, there's another point called other, okay, other. So this one, and we do double, okay, dx equals x minus other dot x, okay, double dy equals y minus other dot y, okay. So we will return mass dot actually absolute value of. We do not need to do absolute. We actually have a power. Okay, power of raising to 2. Okay, you have ds. I'm sorry, actually not. Don't make it so complicated. Okay, so you do mass dot square root. Okay, of dx times dx plus dy times dy. Okay, it will be easier. Okay, so this one calculate distance between 2 points, and we also have a point. Okay, so right now, actually this is a point class. Okay, point class. So right here we do have a array of points. So this array of points, we do have a new point. Okay. Let's do 0, 0, okay. And we have new point, okay. 7, 2, okay. New point. 4, 4, okay. New point. Minus 1, 10, okay. New point. Okay, minus 2, 3, okay. New point. Okay, a minus 1, okay, whatever. We have 6 points. Let me add the number 7, okay, 7 points. Okay, let's assume that we have 8 points, 7 points, 7 points in 2-dimensional array, okay? How to pick the 2 points, they are closest one. They are closest one. Is that okay? How to pick the 2 points that actually they are closest one, okay? So this one, William, how to solve it? How to get the 2 points that they are closest? Okay? James, are you okay?
Yeah.
How to do it? You have 7 points. How to do it? Create a closest 2 points.
Which using a for loop with conditionals to see if each point is closest to each other.
So how to know that I go through all of the combination.
You would do what you were last code, the for loop.
No, this one actually is a K-graph problem, okay? A moment ago, we are discussing the K-graph. You use the upper triangle or the lower triangle, you should solve it, okay? So anyway, here we have a double, okay? Minimum, okay? Minimum distance will be equals actually double that max value, okay? So we need to find a minimum between the points. So we do have index, okay, P1 equals 0, okay. Index P2 equals 0, okay. That's a Sundan, that's a Sundan. So let's start to do it, okay, this way. So we will do upper triangle as well, okay. So we still assuming you do not need to draw the diagram for 7 number. That's too many, okay? You still use your A, B, C, D. That's good enough to remind you how to create the algorithm, okay? So you actually do this, is actually okay. Okay, so based on that, you actually do upper triangle. So for for integer I equals 0, okay? I less than, you can go up to n-1, okay? So basically you actually points the length, okay, -1, and then I increase, okay? So here for, okay, integer, okay, j equals I plus 1, okay, and then j less than ps the length, and j increase, okay? So right here, we may have a double value, okay? Double value distance will be equals the distance function, okay? So we would have actually point I that distance of the point J, okay? So this one, 2 points is point SJI and point SJ, okay? The distance of these 2, and then if D less than minimum distance, okay? Then we will update the minimum distance to be equals the D, okay, and then P1 equals I, okay, P2 equals J, that's it, we finish it, okay. So here at the end of the function, we do system.out.print F, okay. So point percentage D, okay, and the point percentage D, okay, has the minimum distance of percentage 0.4f, okay, change line. So here at the end, we'll print P1, P2, and also minimum distance D, okay. That's it. The calculation of the 2-dimensional point okay, main function, we do system.out.print. Okay. So here we do run this program called get closest. Okay, and the point is called points. Okay. We call that function where points need to be static. Okay. So this one is also getting the K-graph problem, okay? I'm trying to review different algorithms for you, so you need to remember them, okay? Whatever we actually finish. So 0.5 and the 0.1 is 1.414, okay? Let's look at it. So 0.1 is 72, okay? 0.5 actually is, let me see, 0.1 and 0.5, okay? 0.1 is this one. 0, 1, 2, 3, 4, 5. Okay, this one is like this. Okay, this one is that. So it's 1 here. Actually, this one actually has 3. 0.1 and 0.5. Let's see. Distance will have that. Okay. 0, 1, 2, 3, 4, 5. Okay. 0.1 is 72. Wait, distance. Let me look at the distance. Okay. Maybe distance is wrong. You have the x is dx equals the difference of the x. dy equals the difference of the y. Okay. So let's actually print out each pair of the distance. Okay. So right here, let me to debug. Okay. To debug, let me print out all of the distance. Okay. Let me make sure. Okay. I don't want to create problem. So here, let's see, we do have many combinations. So the minimum do is coming up here, okay? Minimum is over here. So we do have a combination that actually, so this one is 0, 1, 0, 2, 0, 3, 0, 4, 0, 5, 0, 6, 0, 7, 1, 1, 1, 2, I'm sorry, 0, 1, 0, 2, 0, 3, 0, 4, 0, 5, 0, 6, 0, 7, and then 1, okay, let me see, something wrong, okay. This one we do, let's print out the I plus, okay, J plus, okay, print out the I, J, and distance, okay. So here we do have 0, 1 is 0, 1, 2, 1, 3, 1, 4. So 1, 2 is 5. 1, 5 actually is this, okay. 1, 5 actually is this. But my point 0, 1, 2, 3, 4, 5, okay. It's my 1, 5. So actually ds dy. Oh, okay, here I have a typo. Okay, that's why. I think I know the number is wrong. It should be minus, it's not equal. Okay, so actually there's an x at that. So it's okay. Still 1, 5 is the minimum, but it's 3.16. Okay, but that's okay. Now I remove the bug. Okay. Anyway, this one, let me comment it out. Okay. Okay, so this one also is trying to come out with the minimum distance between 2 points. And it's also a K-graph problem. Okay, so K-graph is the way you traverse through two pair of two combination. Okay, remember where you should go to do traversal over it. Okay, that's very important. Okay, that's the algorithm that we cover today. So today we actually cover the algorithm of the generating each digit. Okay, and also cover the exact word. Okay, cover the formatting and cover the K-graph problem. Okay, cover the K-graph problem. Okay, the minimum distance algorithm we cover it. Okay. Okay, so for the rest of the time, actually, any questions so far? Any question on the AP exam? Any exam or anything that you don't know so far? Everything related to AP comes out A working is okay. Damon, are you okay?
Yeah.
Any question?
Well, I guess I have a question, but it's just in general, like for AP, you know how like some things are not tested. If I use a thing that's not tested, will I get marked off?
I think your question is, let me try to understand your question, okay? If you use something that actually not covered by AP, is that okay? Is that a question like that?
Yeah, basically if I use like for example like character or character add.
Character or character add? Character add is tested.
Wait, it is? I thought it wasn't.
No, it is.
I mean
add is-
character then.
Which character?
Just like char. The variable.
The variable is tested. Why not?
Wait, but I saw last time I read it, it says it wasn't tested.
Who said that? Which document you see?
College Board.
Can you show your screen? Yes.
I'm searching right now. I
Yeah.
believe it's not tested.
No. Character is tested. Character is tested. Character, integer, double, boolean, these are all tested. String are tested.
Oh, okay.
Okay, so
So if
let's
I use something that's not tested, will it get marked off?
no problem. Okay, the only thing that you cannot do is that, okay, we try to ask you to find an index of a string over a certain pattern, right? So if this one is exactly the same as index of, for example, and then you directly call a function called return str that index of pattern, right? That's not okay. Well, here actually index of is tested by AP. Even if you write this one, it's okay. But for some function like split function, if you use a split function and then the problem asks you how to split a string, then that's not okay. You cannot directly call a function to solve it. That's not okay. Then you need to write the whole split function. But if there is a certain problem, you use a split function, but the whole purpose of the function is not to split some string. That actually is okay, valid. You can use something not covered by the AP. It's okay. Is that okay?
Yeah.
It's said that you need to use it correctly. You use it in the wrong way, you will also get deduction.
Okay.
Okay, but that's a good question. Any of the thing that not covered by AP subset is okay to use. It said that if that is a direct solution, okay, then you cannot use it. You cannot directly call something. Okay, so there's a subset of the AP subset. Okay, you primarily is suggested to use the AP subset in AP exam. Okay. You have to follow the this whole thing. This whole thing is needed. Okay. This whole thing is what is tested. Okay. So there's no such thing that character is not tested. No, its character is tested. Okay. Every function that this tongue over here is tested. Okay. And if you use some function not listed in here, it's okay. That's actually okay. But only that you cannot. That should not be a direct answer. So if they want you to calculate the length of a certain string or something, it's already calling other people's function. That's not okay. That's one thing. Second, if the function is defined in part A, but part B need to use it, you must call part A function. You cannot invent a new one in the part B. Otherwise, you will also get deduction. Is that okay? Damon, is that okay?
Yeah.
If part A try to find the length of the string and part B need to use that function, you have to call the one defined in part A. You try not to recreate the part A again in part B, then you will get deduction. Okay?
Okay.
Okay. Any other question? No? How about Henry? Do you have any question?
No, I'm good.
You're good? How about James? Do you have any other question? Anything related to AP concept, A would be okay to ask, okay? So James, you also have no question. How about William? Do you have question?
No.
No? Okay, no, we are up to here today, okay? We finish the this one, okay? If no question, we are up to here, okay? Thank you.
Thank you.
Good night then. Good night. Bye-bye.